All right, well, I've got 10 o'clock, so let's get started. Thank you, everybody, for joining us for today's coffee break. My name's Aaron Morris. I'm a sales engineer with Long in Colorado Springs. And today I'm joined by Jason Hornsby with MacroAir. And Jason is here to talk to us about MacroAir's HVLS fans and how we can visualize destratification with their AirViz program. So Jason, thank you for being with us here today. And why don't you take it away?
Thank you, Aaron. It's glad to be here. I'm glad to be part of Coffee Break and Partners with Long. So yeah, we're talking about HVLS fans. We're going to talk a little bit about the invention. We'll go through some applications, some of our different fan types, and then we will talk about some of our tools to help you, place and size fans for your projects. Little quick introduction on myself. Again, Jason Hornsby. I've been in the HVAC industry for nearly 30 years. Been with Macro for about 8. So I have some experience with HVLS fans. MacroAir is built right here in the United States. We're based out of California. So yeah, MacroAir. We are the original inventors of HVLS fans and the category. I like to show this picture. This is a picture of our original inventors. With a 10-blade, first invention 10-blade design, a little bit different blade width than what we have now. Over the years of being the inventors of HVLS fans, we've pushed the boundaries, we've redesigned, we've changed our blade count, our blade width, our profile, as just to become the best HVLS fan on the market. We want to be able to push the most air while being efficient and giving longevity to our fans. And we've done that. We've proven ourselves. I go all across America and I look at all these distribution centers, and they have different brands in there. And I'm always proud when someone points at our fan and tells me that fan's been there the longest. It pushes the most air and it lasts. So we are the original inventors. HVLS stands for high volume, low speed. I've seen people mess that up and call it high velocity, which we're actually exactly the opposite of high velocity. So it's a large column of air at a low speed. All of our fans, you can adjust the speed to get the velocity right where you want it. They're variable speed. You can put our fans in forward and reverse. So all of our fans have those features on it. We do have we're not going to go into today a lot of different, options for our fans, but we do have different control options as far as multi-fan control, analog control, digital control, and we also can hook into building automation systems. We have a lot of options there as far as dual control, local override, and things like that. So I'm going to jump right into it of why these fans were invented. Our owners were given a task by the University of California, Riverside to come up with a better solution to cool dairy cows other than the high-speed fans you see on the outer wall of this barn. So they invented the first HVLS fan. Of course, it's not the design that you see in this picture. From what I've heard stories, it had belts and pulleys, and they were just trying to build a big fan to see how it would work. Of course, over the years, we've come to a very efficient design. But anyway, they put these HVLS fans over the cattle, over these dairy cows, and they actually conducted a study in the heat of the summer. And after the study was conducted, the cows under the HVLS fans produced, 15 to 20% more milk. So it's simple as this equates to humans. We're not trying to get more milk out of humans, but we're trying to get more productivity. So anybody that's hot, you're going to slow down as it heats up. And so it's really been great. I will show you this study that was performed by NASA. As you can see on the left, effective temperature, as that rises, the middle column, you get a loss in output on your workers and loss in accuracy. And as you can see, as it gets over 100 degrees, big 62% loss in output, and it's really unmeasurable, the loss in accuracy. So that is the return on investment for your end user. He's going to get more productivity out of their workers. The workers are going to be happier. It's going to boost morale in the workspace. And of course, when, this is where when HVAC is not present, you're actually going to get your return on investment is going to be in energy savings. People are going to be able to raise their set points or lower their set points, whether it's winter or summer. Here's a depiction of the winter. Being in Colorado, I've been there. I'm actually from Louisiana, so we don't get the extreme weathers you get. But this is a depiction of what happens in the winter. You can see as your 90-degree air hangs up top, your 60 degrees down low. When you put in an HVLS fan, of course, you're going to want to run them in reverse in the winter. You're going to destratify and get an even temperature. So you can see that it's, you get a more even temperature, 72 degrees up top, 70 down low, versus the 90-60 split. We do have different models, and depending on your application, you'll have to decide which model is going to be correct for you. The top is our gearbox models. These models have been around since the late 90s. This is our first invention. We call them the workhorse of the industry. We have direct drive models. MacroAir was the first inventor of the direct drive HVLS fan in 2014. And since then, we've re-engineered. We've always pushed the boundaries, and we've come up with a whole new line of direct drive models. And we have new models that we'll be introducing next year. But once again, just to talk about the gearbox models, these are the workhorse of the industry. They do have some electromechanical noise, typically in an environment of a distribution center where you got forklifts, or in an industry where there's some noise. You're not going to hear anything. The only time that you may want to think about doing a direct drive in an application is if you just want the technology, or B, it's a super quiet environment and you don't have that electromechanical noise. Most people don't hear that noise anyway, but you'll just have to decide which fan is right for your application. We got a 3-blade design in here, as you can see, and all the way to the bottom right, our model 370 is a smaller fan for smaller spaces and lower ceilings, and only goes from 6 foot to 12 foot diameter. We do have some spacing requirements for fans. We want to be 1.5 times the fan diameter away from a wall. It's not on this picture shown, but you want to be 3 times the fan diameter away from another fan. And there are other requirements as far as you want to be 10 foot above finished floor. You want to be 3 foot below sprinkler heads, and you want to be centered between 4 sprinkler heads. And on our website, we have all this information. Call your Long associate, get with our applications engineer. We'd love to help you, with all your clearance requirements. So this will go straight into the tools, and really what we want to talk about in this coffee break section of what's available to you as a contractor, engineer, architect. This is our CFD modeling. We came out with our first generation CFD modeling computational fluid dynamic model in 2014. We call it the AirViz. So the graphics that you see here is our Gen 1. We could create a 3D image of a space, length, width, height of the building, put a fan in there, and we can actually see how it reacts. They say invention is the mother of necessity. So one of our customers called, and they wanted us to price and size and place a fan in their building, and they did the same thing with a competitor. And the customer simply asked the question, who's right? You're saying this size, they're saying this size, you're saying this many fans, they're saying that many fans. So that's when we came up with this AirViz, just to show our customer, hey, we can put a fan in your space, here's your profile velocities that the fan creates, and here's the coverage. And we do comply with ASHRAE 55 standards. This is a side view of the profile velocities, and this is an overhead view. And once again, this is our Gen 1 graphics. And I want to show you, now that we are in our Gen 3 graphics, this is our new AirViz that just came out. I'm gonna go through a couple of slides. I'm going to show you what we're doing. Then I'm actually going to show you a video of one of our engineers creating the space, and just to show you how simple it is to operate. Here's an overhead view. You can see they've got columns drawn in. They've got a couple of aisles or shelving drawn in, so you can see as you create this space. I don't have the end results, but this is show you that we can start putting objects in buildings, because of course all the buildings that we start off with is a blank slate of length, width, and height. But what happens after you put objects and obstructions in that building? What does it do to the airflow? So there's the overhead view. Here's the side view. So here's another view with the models. You can pick different models and put them in these spaces. Once again, here's another view with 2 fans. Just a whole different view here. And this is the video. It's super cool. You can see this is our designer. He's going to build a space. He can grab it, turn it. You punch in your length, width, and height of the building. You can stretch the building, make the building bigger. You can make it higher. So you can create your space for actually what it is. You can pick different model fans. You can put them in the space. And then you can also play with the height of the fan and see how the air reacts. And I tell people all the time, the fans, they do great at higher mounting heights. Your air is able to cone out and spread. So very versatile. You'll be able to put columns in there. As you can see, we're putting all kind of different items for this AirViz. So as you build your space and you say, hey, you can throw a forklift in the way, you can throw a table, a desk, a chair. I mean, there's all kind of different items that you're going to be able to grab and put in your space and see how the air reacts. So we're really excited about this new AirViz. It'll be available soon. We have an applications engineer on staff that can help you design. You can send him plans. He can plot plans for you, size fans for you, help with, like I said, obstructions, clearances to lights, or any other obstructions you have in the building. So super excited about it. Once again, glad to be part of Coffee Break. When you think of HVLS fans, high volume, low speed, think of MacroAir. We feel we have the best fan in the industry, and we're constantly putting tools out there to help. So, yep. Aaron.
Jason, thank you very much. That's a great tool. Really takes the guesswork out of sizing the HVLS fans. Appreciate everybody joining us today. And I hope you'll join next week when Bill Rohn with Long will be with Brian Stinnett from Oxygen 8 to discuss ventilation with electrification, building ventilation in cold climates without gas heating. Thanks, everybody.